Welcome everyone. In this series I'm going to go over me solving the fall 2014 Math 234 final exam, and I'm just going to talk through my ideas and what I'm thinking about as I see these problems. For better or for worse, you're going to hear kind of how I would approach these problems. If you don't already have your own copy of this final exam printed out, right, you can get one off of the main course site. I'll also put a link for it in the description down below. Alright, so let's get to it. I'm going to do the first page of multiple choice problems in this video. So let's skim through all of these kind of header pages, and here is our first page of multiple choice. So okay, a parametric equation for a line through a given point perpendicular to the plane is given by, and we have some choices here. So okay, first of all, I need to remember for a parametric equation for a line you need two things. You need a point in which it contains, and you need a direction. So here's the point in which it contains, and let's maybe go ahead and write down what our formula was. So r of t is equal to some r naught, so that's the point in which it contains, plus a direction vector times our parameter t. So now I need to figure out what should the direction vector be. Well, the direction vector, that's given by this fact that it's perpendicular to the plane, and then it specifies the plane there. So I need to know, okay, what vector is perpendicular to the plane, aka what vector is normal to the plane. So I'm looking for the normal vector for this plane. Okay, so staring at the equation of the plane, remember we're looking at the coefficients for x, for y, for z, and so I think I'm going to get maybe -1. The coefficient in front of the y is -1, and the coefficient in front of the z is going to be +1. So this is the normal vector, or the vector that's perpendicular to the plane, so that's what I'm going to choose to be my direction vector. That's going to be my v, and here is my r naught, the point that I want it to contain. So let's go ahead and maybe put these things together. So I'm going to have the vector 1, 2, 3, plus -1, -1, 1. Oops, that's a horrible one. Times t, and maybe let's go ahead and combine these things a little bit. So I'm going to have, let's see, 1, and then I'm going to have -1 times t, so that's just going to be -t, and then I'm going to have 2, and then I'm going to have -1 times t, so that's going to be just -t, and then I'm going to have 3, and then I'm going to be adding to it 1t, so that's just plus t. Alright, now staring at our choices, actually it looks like D right here perfectly matches up with my solution, so I'm going to go ahead and choose D as my answer in this case. Alright, moving on. Problem number 2. Suppose that we have some nice relationship here. X squared plus 3xy, let's see, is equal to 7. Which of the following is true? So remember there was actually something about this, right, with these dy dx's, back when we first learned about the chain rule, right, the multivariable chain rule, there was something that said like dy dx is equal to negative capital F, and this is a partial derivative with respect to x, divided by capital F and the partial derivative with respect to y. Where, right, this capital F was some function in terms of x's and y's, and this was supposed to be equal to some constant. And it could be any old constant here, it really didn't matter, but so long as there was a constant on that other side, that's what kind of made this all work. So this was an actual property of, kind of a result from our chain rule for multivariable calculus. So let's go ahead and calculate this out. So I'm going to have negative, let's say the partial of f with respect to x. So here is my capital F right here. If I take the partial derivative of this with respect to x, I think I'm going to get 2x plus 3y divided by, and the partial of capital F with respect to y. So let's see, I think that's just going to be 3x. Okay, so looking at my answer and comparing against my options, it looks like, again, D, 2 D's in a row here, actually matches up with my result up here. So I'm going to choose answer D. Okay, moving on, problem number 3. Suppose I have some little f, and it has x's and y's in it. And let's see, x itself depends on v and u, y also depends on u's and v's. Which of the following is true? And we're looking for a partial of f with respect to u. So again, this is kind of the chain rule stuff, right? If I have f depending on x's and y's, and I have maybe x depends on u's and v's, and I have y depends on u's and v's, right? And my goal is to find what is the partial of f with respect to u. So we remember we kind of have to travel down each one of these branches here. So f go down to the u's, f go down to the u's, so something like this. And so according to the chain rule, this is going to be the partial of f with respect to x times the partial of x with respect to u plus, right, now we go down the other branch, the partial of f with respect to y times the partial of y with respect to u. So this is what I want to calculate out in order to solve this problem. So let's go ahead. The partial of f with respect to x, so that's going to be 2x plus 3y. The partial of x with respect to u, so the partial of x with respect to u, I think that's just going to be cosine of u, plus the partial of f with respect to y, that's just going to be 3x, and the partial of y with respect to u, that's just going to be 1. Okay, now as I go and I look at all my answers here, right, I don't have any ones that have x's and y's. So they've went ahead and they've traded it in, all their x's for, let's see, negative v sine u, and all of their y's for u plus sine v. So let's go ahead and do the same thing here. So I'm going to get, let's see, 2 times x. So I'm going to write maybe negative 2v plus 2 sine v plus 3 times y. So 3u plus 3 sine v times cosine of u plus 3 times x. So 3, let's see, negative v. So let's do negative 3v. And then let's do plus 3 sine v. And again, this is times 1 technically. And so when I go over here, right, I see a lot of these that have cosine u and then nothing over here. That's going to be like the same thing as multiplying by 1. Cosine of u, good. This one has kind of grouped interestingly. Let's see if maybe either a or b works out. I like the setup for those at least. So I see 3u, and here's 3u. I see negative 2v, and here's a negative 2v, and I see 5 sine v, and there's 2 plus 3, so that's going to be 5 sine v. Okay, so far so good. Now moving on into the next one, I see negative 3v. Oh, but this is negative 3u, so that one doesn't work out, right? Because I needed 3 y's, and the y's have a u and a sine v. This looks like it has them switched. So, okay, A doesn't work out. How about for B? I mean, B looks... Oh, and in fact, I made a little bit of a mistake here. Well, that's actually nice that they they helped me catch this, right? Because in the x's, I have sine u, right? And this, I wrote down sine v, right? So this is supposed to be 2x. So 2x is supposed to be negative 2v, and then plus 2 sine u, right? Okay. So I made a mistake. Those actually didn't group together. The 2 sine u and the 3 sine v, that wouldn't have grouped together. So A is now double wrong. I'm glad I didn't make 2 mistakes, otherwise I would have gotten tricked. All right, well, let's go and now maybe look at B. So I have 3u. I have negative 2v, I have 2 sine u, yes, and I have 3 sine v. Okay, this is starting to look good. I have the cosine u, yes. I have negative 3v. Well, let me check, because that's not what I have written down, but now I'm paranoid that I did something wrong again because I made one mistake already. So let's go ahead and double check this again. This is supposed to be 3x. I know that for sure. So, okay, 3x. So 3x is going to be negative 3v plus 3 sine u. Negative 3v plus 3 sine u. Okay, so let's double check. Negative 3v, 3 sine u, 3 sine u. All right, that looks good. I am happy with B. But yes, this was maybe a good indicator, right? You really do have to double check your work here because especially with u's and v's and stuff like this, you can easily mix those up. Same thing I found with the thetas and the phis, right? You have to kind of take those slow. I think I got the right answer here. We can check the solutions, but right, you have to take it a little bit slower than maybe I was doing, because otherwise you can switch your u's and your v's. All right, let's do one more, the directional derivative. Directional derivative, we have some f at the point 2, 0 in the direction of I and negative 2j. It's given by which of the following? So we need to remember the directional derivative. Directional derivative is given by the gradient of f at our specific point dot u. And this is supposed to be a unit vector that's in the direction that you'd like. So in this case, our vector is, maybe I'll go ahead and write it as 1 comma negative 2. And I need to be paranoid that that's not actually a unit vector. So, okay, if I wanted to make this a unit vector, right, I would go ahead and I would do the square root of 1 plus 4. That's 1 squared and negative 2 squared. That's going to be the same thing as square root of 5 altogether. All right, so that's what this vector is, the unit vector that I'm in the direction that I'd like. Let's do the gradient of f at p. So, okay, the gradient of f. So let's go ahead and take a look here. If I take the derivative of this with respect to x, I'm going to get 2x y minus 1, comma. If I was to take the derivative of it with respect to y, I think I would get x squared, right? So the x squared is constant, it's along for the ride. So when I take the derivative of this, I just get 1. So that's x squared times 1. And when I take the derivative here, that's going to be negative 4y. So now let's go ahead and plug in our specific point. So our point here is 2, 0. So if I plug in 2 everywhere I see an x, and 0 everywhere I see a y, let's see, I'm going to get negative 4, 4. Okay, now I need to dot product that along with my vector u. So I'm going to dot product this with u. So my u in this case is 1 comma negative 2 over the square root of 5. And now it's a good thing that I kind of paused and I looked at these answers over here, because I would have kept going maybe with this. But actually we see now that the answers don't actually have the dot product evaluated out. Luckily though, it looks like C perfectly lines up, right? Negative 4, 4 dot 1 comma negative 2 over root 5. So I'm going to choose C. Alright, this has been page 1 of the final exam from fall semester 2014. Our next video we're going to cover the next page, right, which has some fill in the blank stuff. Alright, I'll see you guys then.